Yes, I want to welcome you to my YouTube channel. This is what we have been waiting for a long time. Please do not forget to subscribe to this channel. It's very important. Whenever we post uh, important information or lesson like this, it's good for you to be aware. But you will not be aware except you subscribe. So please don't forget to subscribe. We still have much more things to send to you in this through this channel. All right. Now this is the question one of the 2021 Waec Physics Practical. I had initially proposed a question which required that we vary the period of oscillation with the mass, thinking that the masses will be varied with the period of oscillation. But looking at the experiment, we found out that the mass do not actually have significant effect on the period of oscillation. On that note, by critical observation, we discovered that no, the masses are going to be kept constant, and we are going to have two pairs of those masses, one on the left hand side and the other one on the right hand side. Okay, so and they're going to be constant. Then there are two possibilities. What are the possibilities? In this experiment, you are not going to alter the distance between the thread. Okay? You're not going to alter it. Because of the presence of the masses, you are not going to alter the distance between the thread. But you can either keep d, which is the distance between the thread constant, and the length of the thread constant, and then vary the distance between the masses with the period of oscillation. Another possibility is to keep the distance between the threads constant, keep the distance b between the masses constant, and vary the length of the thread with the period of oscillation. But let's look at the background theory behind this experiment. This is a bifilial suspension, but this is not an ordinary bifilial suspension. This is a loaded bifilial suspension. Whenever a mass or set of masses are added to a metal rule like this that is suspended by two parallel threads of equal length, the masses added are called auxiliary masses, and the entire system is referred to as loaded bifilial oscillation. Now, what is the period of oscillation of a loaded bifilial oscillation? The period of oscillation T is given as 2 pi root 4L then B squared, right, over G D squared. So if you open this bracket, you have T squared equals to 16 pi squared. If you square both sides, you have T squared equals to 16 pi squared LB squared over GD squared. Good. Now, if you are keeping D constant, which is the distance between the threads, and you are keeping L constant, which is the length of the thread, then T squared equals 16 pi squared L over GD squared, then B squared. Right? So you are going to be plotting the graph of T squared against B squared. And the slope of the graph, of course, the graph is going to be a straight line graph passing through the origin because there is no intercept. So you have T squared here, you have B squared here. Okay, there's going to be a straight line graph passing through the origin, and the slope of the graph S will give you 16 pi squared L over GD squared. Okay? And from here, since 6 pi squared over GD squared is constant, L is also constant, but from the slope you can ask to evaluate L, which is the length of the thread. And how do you do that? Let Q be equal to 16 pi squared over GD squared. Don't forget, in the question, you will be asked to make sure you measure D in meters.